Hey everybody, it's Mr. Dollar, also known as Peace Daddy. Today we are going to have a lesson on the advanced games for the memorization of multiplication. If you're working from home, you're going to go to virtualmontessorimaterials.com, and once you're at that website, you'll see a lot of boxes with different Montessori materials in them. And you're going to choose the picture box that says bead bars. So virtualmontessorimaterials.com, and then choose the box that says bead bars. And we're going to go over two games today, the Magic Zero and Factors of a Product. And there's going to be a couple of vocabulary words that are new today to some of you. The first one is prime numbers. And the second one is composite numbers. Okay, so first game is the Magic Zero. I'm gonna move my camera down so you can easily see my rug that I'm working on. And for the Magic Zero, you're just gonna get 10 bars of the same color or the same type. So for this example, I'm going to use 10 of the 3 bar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want you to record that problem as 3 times 10. And I'm going to write it in a special way where I write the 0 in my 10 with a red marker like that. And you can write yours with a red colored pencil or a red pen, but we want to have the 0 in red. And then I want you to count to find out how many you have. So if you have 3 bars and you have 10 of them, we're going to count them together and see how many we have. So the first one is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So the answer is 30. And you need to write that down with the 0 in red. And so why is this game called the Magic Zero? Well, it's called the Magic Zero because it doesn't matter which number you use. We use 3 in this example. As long as you multiply it by 10, the first factor in your problem, which in this case is 3, is going to appear in your answer. The first number in the product is 3. And then the last number will always be 0. Okay, let's try it again with a different one. This time, instead of using 3, let's use 5. So I'm going to take out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to write down that problem the same way as I wrote the other one. 5 times 10. And I'm going to write my 0 in my 10 red like that because it's a magic 0. And then I'm going to count them up. We know that the first one is 5 because this is a 5 bar. The second one is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So 5 times 10 has a magic 0 as well, because one of my factors is 10. So that 0 that's in the 10 moves to the product. And this factor shows up here, and the 0 from this factor shows up here to give me a product of 50. Now, do you have to count all the beads if you have already mastered skip counting? Nope. You could count by 5s just as easily, right? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, like that. The thing to remember is that the 0 is magic because it appears in your answer, or it appears in the product of your multiplication problem. So that's called the magic 0. I'm going to clear the board and get ready for our next game. And the next game is called the factors of a product. So in the factors of a product, the direct aim is that you realize that some of the products can be formed by a few of the same bars. And some of the products are going to be formed with a lot of different bars. And some of them can only be formed by one bar. Okay? And the ones that can only be formed by one bar, those are prime numbers. All the other ones are composite numbers. So remember, I said at the beginning that those were going to be 2 vocabulary words that we were going to go over. So prime numbers and composite numbers. So as we're working through this lesson, through this game, see if you can think of a definition of prime numbers and composite numbers. See if you can write down how they're different. So I'm going to start by laying out a product with the golden bead material, and I'm just going to choose 12. So let's start out with 12. So we have a golden bead bar of 10, and then we have a 2 bar after that. And we're going to see, you always start at the beginning, you always start at 1. We're going to see if 1 is a factor of 12. So I'm just going to keep a little list over here on the side, and I'm going to call my list factors of 12. Okay, I'll write that a little darker. Factors of 12. And I'm going to try out 1 first. So you can work ahead if you want to, and you can be thinking, is he going to be able to make 12 exactly with just using 1 bars? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I do it? Sure I did. You can make 12 with 1. Okay, 1 times 12 makes 12. So in my list of the factors of 12, I'm going to start out with 1. 1 is the first factor of 12. And then I'm just going to go up systematically. I'm going to start at 1, and then I'm going to try 2. Can I make 12 exactly with 2 bars? Well, there's 2, and then 2 more is 4, 6, 8, 10, 12. I made exactly 12 using 2 bars. So that tells me that 2 is also a factor of 12. So I'm going to put that on my list. All right, what comes after 2? 3. So let's try to make 12, exactly 12, with 3 bars. See if I can do it. 3, 6, 9, 12. It worked. So I'm going to add 3 to my list. So far the factors of 12 are 1, 2, and 3. Now I'm going to try 4. 4, 8, 12. 4 is a factor of 12 because I can use a number of 4 bars and exactly get 12. Okay, keep going. Let's try 5. 5, 10. Am I going to be able to make 12? Nope. The next multiple of 5 is 15, so that won't work. Let's try 6. 6 and 6 is 12. So 6 is a factor of 12. Okay, so I'm going to write that one down. What about 7? 7. Will that work? No, because the next factor, or the next multiple of 7 is 14. 8. Can I make 12 with 8? No, because the next multiple is 16. That's too much. What about 9? Can you use 9 to make 12 exactly? No. All right, so the factors of 12 then are 1, 2, 3, 4, and 6. And you can do this with any number to find the factors of a product. So you start out using the golden bead material, make your number, and then you always start with the number 1, and then try 2, and then try 3, and so on. So let's try a different one. I'm going to clear all this off. I know a number I want to try. I want to try 17. So I'm going to start out with a 10 bar, and then I'm going to choose 7. Okay, so we're going to call this the factors of 17. Now, is one of the factors of 17 going to be 1? Yeah, I'm going to tell you a little secret. 1 is a factor of every number. 1 times 17 will be 17. So I could take out 17 red ones and lay them out, and I would get 17. So I know 1 is a factor of 17. How about 2? Can I make 17 with 2? 2, 4, 6, 8, 10, 12, 14, 16, 18. Too much. I can't make 17 exactly with 2 bars, so 2 is not a factor of 17. So again, we're just working through the numbers. Now I'm going to go to the 3s. Can I make 17 using 3 bars? Let's see. 3, 6, 9, 12, 15, comes after 15, 18. I can't make 17 with the 3 bars. So 3 is not a factor of 17. What about 4 bars? Let's try. 4, 8, 12. Is it going to work? 16. If I had one more, I could make 17, but remember, it has to be exactly 17 with the bars that you use. 5 won't work because 5 times 3 is 15. 5, 10, 15, and I would need 2 more to make 17. So I can't make 17 exactly using 5 bars. So 5's not a factor. 6 is not a factor because 6 times 2 is 12. And 6 times 3 is 18, and that's 1 too many. So 6 is not a factor. Is 7 a factor? Let's see, the number's 17. Maybe 7's a factor. 7, 14, no, because I would need 3 more to make 17, and I have to use 7. 8, 8, and 8 is 16. I would need 1 more to make 17, so that won't work. 9, 9, and another 9 is 18, so that's 1 too many. So guess what? 17 is a special number. The only factors of 17 are 1 and itself, 1 and 17. And when you have a number like that where it only has 2 factors, 1 and itself, that number is called a prime number. So a prime number only has 2 factors. 1 and itself. That's the definition of a prime number. It only has 2 factors, 1 and itself. And the other example that we had was a composite number. Remember, that was the factors of 12. So all the other numbers, if a number like 12 has more than 2 factors, then it's called composite. And there's more composite numbers than prime numbers. Think about all the composite numbers, numbers that have more than 2 factors. There's lots and lots of them, and you can use this work that I just showed you to figure out what those numbers are. How many of them are prime and how many of them are composite. So those are 2 games for multiplication that you can play at home. And I want to thank you for watching. This is Peace Daddy. See you next time.